As we discussed before, we have discussed about switching concepts in the previous slides. So just for recall purpose, these are the things we have discussed already, like what is the basic procedure involved in the switching, what is switching, how learning takes place, then MAC table, CAM table, how it performed, learning. So these are the few basic things which we have covered in the concept of switching. Now we will see some analysis part here. So we'll cover two things. First, we'll start with the basic switching concept and we'll do some basic switch analysis practical. Then we'll try to implement spanning tree concept and we'll discuss various terminologies, and I'll show you various spanning tree terminologies which we discussed, like root bridge, root port, designated port, etc. So let's start with the basic switch. So this is the packet tracer. We use this as a simulator for networking practical or networking. If we want to check something related to networking device like switches, routers, so we can do various operations here. These are not actual devices, because actual devices comes very costly. Devices are very costly. So what we'll do, we'll use this simulator. This is easily available, packet tracer, so we can use this for our learning purpose. So this is meant actually for learning purpose mainly. So for beginner purpose, you can use this simulator and you can learn a lot of things. So I'll just give you an overview how to use this. Okay, I'll start freshly. Let's see. First of all, okay, I'll close it and open it from fresh. Any answer changes will be lost. No. What we'll do, we'll open it freshly. Its name is packet tracer. So this is the fresh things we have opened. Now you can see here, see what is this. These are routers. It is showing here. If you click here, it will show switches. So various network device options are available here. If you go here, it will show in hubs. If you need not to click also, it will just keep here, it will show wireless device. So click, it will just keep your cursor here, it will show connections. So these are the things available. This is your end devices. End devices means your PC, it can be server. So if you want to see what all options are available, you just click on this. So in end devices you have generic IP phone generic. So these are the things you can simulate here. I mean to say that. So WAN emulation, similarly custom made devices. So we don't need all these options. We just need one thing, is like we want to do for now we want to do switch operation. So we'll select switches. So these are the various model of switches available. Okay, so I'm just taking the first one. I'll just take the first one. So sorry, I'll just tell you how I selected. First went to I clicked on the switches option. Then it is showing me various switches available for the simulation. So I'll get any one of them. Suppose I taken first one. Now I want one switch, so I just clicked here, then I moved it to this white space or my project space, and I clicked here. Okay, so I got one switch. So likewise, if you want multiple switch, you can keep multiple switches for it. For now I'm just taking one switch because I want to see how switches behaves when we have when how it will learn the how it will switches will perform learning. So for that, now we'll get end devices also. So we'll take here also first option, and here we will take multiple PCs. So I hope it is okay. So what we did in our topology, for now we want one switch and 3 PCs. Now we want to connect it. So for connecting it, again here we are taking first option, we went to connections, and then in connection we took first option. Now we'll try to connect it. So how we are doing this connection? We are clicking here and then we are going here. So we are doing that many times. We want the number of time we want to connect, that many time we have to repeat this. So one time we did, second time we did, third time we are going to do. What we are doing? First of all, we selected here, then we selected, we have clicked on switch. So in switch, one interface it has taken, then you go to PC and click it here. Very simple. I'll show this again. I'm removing it for your, so that it will be, yeah. So how to delete it? Just click on delete. In your keyboard, just you press delete key. If you press delete key, this cross symbol is coming, then you have to remove this. The cross symbol, you move it wherever you want to remove. For example, if I want to remove PC, delete. First I clicked on delete. First I pressed delete key. So when I pressed delete key, this option, this cross option, it is showing me. So wherever I'll click, that will get removed. So PC I want to delete, PC will get removed. So this is how we need to delete it. Again, I just want it, I am taking it back. So PC1, PC2, PC3 now these things are available. I want to make the connection. I was just showing how to delete it. Now again I want this connection to be there because that is my topology. So I clicked it on first connection itself, and then I have to click on PC because I want connection from PC to switch or from switch to PC. Anyway it is fine. So any place you can click, either here first or here first. So I want connection from switch to PC3. So I'll click on switch first, then I'll drag this, I reach PC3, and then I'll click here. So this connection is done. If you want to see which interface, because switch is having multiple interfaces, how many interfaces it is having, you can see. if you just keep your cursor on the switch, it will show you all the interfaces which are present here. So you can see fast Ethernet 01, 02, 03. Fast Ethernet is something related to speed. So Ethernet, fast Ethernet, this name will tell us what is the speed of the interface. So the number of interfaces present, that many connection a switch can have. So here you can say fast Ethernet 0/1, 0/2, 0/3. So if you put your cursor here, you can see what all interfaces present here. Okay, so these are the interfaces present here, and you can see here it is showing only fast Ethernet 0/1 is up, which means it is connected to PC. So now it is up now, and how you can see here, see it is glowing green. Green means it has come up, and if you are keeping your cursor here, it is showing FA 0/1. So FA 0/1 of the switch is connected to PC. Okay, so we can say from here. If you click here, it will show FA 0/1. Now we want to make another connection, so we clicked here on switch 0 and then PC 2. See, now the switch interface is showing orange. We have to wait for this to become green. So it has become green now. Again, you can see, if you put here cursor on the switch, you can see 0/2 is also showing up now. Previously it was showing only 0/1 up, now it is showing 0/2 up. See, if you are keeping it here, keeping your cursor here, it is showing which interface of switch is connected to PCB. So here you can see FA 0/2 is connected to PCB. Now again we'll make this connection as well. We'll wait for this to go green. So it has gone green now. Now what we have to check? So in a network, actually when we have a switch, plain switch, so we can say it is representing one LAN. One LAN means only one network is involved. Okay, so whatever IP address we are giving to the PCs, all IP address should be present in the same network. So IP address will come along with the subnet. So for now we'll just say like that is a big concept, that is a bit mathematical concept which involves to take like which all IP address are in the same subnet, in the same network. So those things involve some calculation. For now we have to understand one thing. So whatever IP address we are going to give, all should be in same network. So what will give? So depending on class of the IP address, it will give the subnet mask automatically. So no need to worry here. This gateway and all will be needed when you are dealing with a multi-network environment. But here, as I told again and again, I am saying switch means it is only single network. Only one network or one LAN will be involved into that. When you want to communicate with multiple network, you need a router. So when you have a switch, by default you can have only one network. When you have a plain switch without any VLAN configuration, then all the PCs connected or all the devices connected will be in the same network. Okay, so this is the first IP we have given to PC3 is 1.1.1.1. Now we'll minimize it. We'll use 1.1.1.2. See, we can see whatever IP we are giving, it is taking the subnet mask automatically. So if you need more info regarding this subnet masking, subnet and network IP address classes, it is not that difficult concept. You can go through, but there are some classes like class A, class B, class C, class D. So your class, your IP address along with subnet mask will decide in which network it is, whether they are in the same network or different network. So this IP address and subnet mask together will decide in which whether they are in the same network or different network. So for now I am giving IP address and subnet mask in such a way that all the PC should be in the same network, because switch do not allows communication between different network. So how I am, first of all, okay, if I want to configure IP address, as you are seeing here, go to PC. Going to PC means you have to double click on PC. It is simple. When you go here, desktop IP configuration 1.1.1.3. by default it will take subnet mask depending on the class of the IP address. So this is done. Now if you want to see what is the IP address configured, you just keep your cursor on the PC. So if you keep your cursor on the PC, you can see PC1 is having IP address of 1.1.1.3. PC2 is having IP address of 1.1.1.2. PC3 is having 1.1.1.1. You can see in the switch, if you put the cursor on the switch, you can see 0/1, 0/2, 0/3 are up. Okay, and when you will see here, it is showing you, see, first here it is showing what is the IP address you have configured for PC. Then you can see link, IP address, IPv6 address, MAC address. So link is up, IP address 1.1.1.1/8. so IP address along with subnet mask, as I told. IP address along with subnet mask will decide what is your PC's network. IPv6 address, we don't need it, so we didn't configure. MAC address. So MAC address, what is this MAC address? And for switch, this MAC address is important because switch will learn this MAC address only, and depending on MAC address learning, it will take the decision. So you can see PC0, so we'll just see this last 4 number. It is actually in hexadecimal, so it is showing 7C32. Okay, so this is some unique hardware number assigned to the PCs. Okay, that is how we can understand. This is the unique hardware number or a unique hardware ID assigned to a PC when they are manufactured. So you can see here 7C32 at the end, 009007BE 0CBE 7C32. Similarly 0030F276BD51, and for PC2 also it is. So for every PCs this MAC address is unique. Okay, now if we go here and it will see how you will see if you want to see what is present in the MAC address table, you can just, okay, I'm closing it. I'll show it again how we'll go to switch. So PCs and all, this whatever communication will happen, that will happen between two PCs, and for that our switch configuration we have to check, or we have to see what all entries are present. So we have to go to the switch. So first of all we'll go to switch CLI. So in CLI mode we can see show MAC address table. So here we are seeing BD51. Okay, so what it is showing, see, BD51 is the PC1's entry into switch. Now what we'll do, we want to communicate between different PCs. On PC3 IP configuration is done, so I'm closing it. Now I want to perform a communication operation. Communication operations means we just want to check whether we have connectivity or not. Okay, so what we'll do, from PC1 to PC3, so this ping is a way of checking whether we have connectivity is there or not between two devices, so whether we are able to reach or not. So once we are able to reach, then only we can set up any communication. So we are at PC3 whose IP is 1.1.1.1. so I want to ping to, suppose, 1.1.1.3. okay, so here we have, or better, we'll simplify it. What we'll do, we'll change the IP address. Why I am changing, I'll tell you. See, now, or we'll change the name of the PC. which is easy for understanding purpose. So PC1 is having 1.1.1.1, PC3 is having 1.1.1.3, PC2 is having 1.1.1.2. So it is sounding better and it is easy to understand, like PC1 is having 1.1.1.1 IP, PC2 is having 1.1.1.2 IP, PC3 is having 1.1.3 IP, 1.1.1.3 IP. So now if we are into PC1, okay, now I'll open it freshly. Okay, so when I have removed everything, I have changed the name and name of the PCs. Now we don't have any entry here now. Okay, now so what we can say, switch is fresh and it has not learned any MAC address. So switch will learn the MAC address. Okay, how it will learn? When will initiate a communication. So again, if I double click on this PC1, I'll go to this config, then device must be powered on. So device is not powered on. So we have to check why it has gone down. Okay, so we have to see why it has gone down. Looks like some problem. So now it has it is up now. So what we'll do, we'll try to, okay, first of all we'll see what is the MAC address table showing us. We can see here. So you can see MAC address table is fresh, nothing is present here. So now what we'll try to do, we'll ping from PC1 to PC2 first, okay, not PC3, PC2 first, okay, and then we'll see what is happening. So PC1 is 1.1.1.1, PC2 is 1.1.1.2, PC3 is 1.1.1.3. Okay, so we'll try to ping from PC1 to PC2, means we have to ping to PC2, that is 1.1.1.2. So we'll go to PC1, command prompt and we'll try to ping. Ping is a way of checking whether we have connectivity to the destination point or not. Our destination point is PC2, that is 1.1.1.2. Okay, so these things, if you are not able to understand, that is fine. So what this ping will do, it will send a message to other device or to other IP, we can say here 1.1.1.1 has sent a message, ping message to 1.1.1.2, right? Hi, are you present? So 1.1.2 1.1.1.2, that is PC2, is replying yes, I am present. So totally how many times it is sending? 4 times it is sending message and 4 times it is receiving the reply. It means we have the connectivity. Lost is 0. So 0% loss means we have the connectivity, and switch in the middle is providing us the connectivity. It is providing us proper connectivity. So we are able to reach to PC2, that is 1.1.1.2. So now you can check your switch MAC address table. See here. So what you can see here, show MAC address table, it is showing us in the port, switch is having multiple ports, FA0/1. At FA0/1, which PC is present? How you can see here? So PCs, how they will do, how a switch will know about the PC? By using the MAC address. As I told, every device has having a unique hardware MAC addresses. So this is the hardware MAC address of PC1, or let me check, we'll see what it is. So you can see here E8A2, this complete thing is showing us the MAC address. Okay, so same thing you can see, FA0/1 is connected to PC1. So FA0/1 is connected to PC1, so it should be PC1's MAC address. So you can compare it. If you keep it here, you can see 000217BB E8A2. So here when you try to ping, it has learned MAC address from the ICMP messages or from the ping messages. From the ping message, it is getting to know at which place, at which particular port of my switch, which all PCs are present, and it will make an entry for their MAC address. FA0/1, it will make an entry of PC1. Similarly for FA0/2, it will make an entry for PC2. You can see 00D0 FF88 22AA. So you can see here. We'll go to switch 00D0 FF88 22AA FA0/2. Okay, so this is how switch will make an entry. Again, we'll perform same operation for PC3 also. So we'll go to PC1 and we'll try pinging PC3. We want to see whether we are able to connect or not. So you can again see here, packets sent equal to 4, received is equal to 4, lost is equal to 0. So 0% loss. Now again we'll go here and check what is our MAC address table. So here you can see at FA0/3 it has learned PC3's MAC address. Okay, so what it is doing, it is displaying us what is the content of the MAC address table. So these are the VLAN and ports. So these things we should not these things are VLAN and all we need to configure. Later we'll see what is VLAN, and which dynamic entry means it will learn dynamically. We are not configuring it statically. So this is dynamic configuration. When we are communicating through the device, when you communicate, some communication is happening through the switch, it is learning it dynamically. So this is the main thing, what is the MAC address you have learned and on which port you have learned. Okay, so this is the basic switch. Next video will discuss about spanning tree protocol and loop avoidance. Thank you.